guys, welcome to Algebra 1, Lesson 50. Now today's lesson, it's not complicated, but there's a lot of information. So for this lesson, we're really going to be just going through your book together through the lesson. So if you don't have it out in front of you, I want you to get it and open it up to page 182 so we can go through it together. We're talking about polynomials. And we have talked about these before in Algebra 1/2. So this is not entirely new, but you may have forgotten between Algebra 1/2 and everything that's happened and now. So here we go. We're talking about polynomials today as well as addition of polynomials. So far it shows you on the bottom of page 182, see right there, these expressions. So I want you to look at those. It says, thus far we have encountered expressions such as x to the negative 3 plus m over x, 2y over x3, expressions all like that, okay? All of those things there, you can take a look at them. They're all algebraic expressions or mathematical expressions. They're individual terms or sums of terms, but most of the more complicated ones from A through D, so if you look at the ones in A through D, those have no special name. They're just terms or expressions. So algebraic expressions, terms, that's all that we have for them. But there are simpler expressions, the ones in E through I. If you look at those, there's no division in those. There are negatives, but there's no division in those. I want you to look at that carefully. No division, okay? We give these expressions a special name of polynomial. So polynomial, it's a very, very simple thing. They are the simplest type of expression we can have in algebra. So a polynomial, it has this basic form. AXN, where A is any real whole number. It can be positive or negative, but it has to be a real whole number. X is your variable, and N is your exponent. But your exponent, again, your exponent has to be positive, because if it's negative, remember that means that you have division, because to make it positive, you have to put it on the denominator. So your N has to be positive. So for example, 4x squared. 4 for A, x for x is your variable, 2 for your exponent, so that fits the polynomial form exactly. Here I have negative x, so negative 1 for your A, x for your variable, 3 for your exponent, excuse me. Negative 7. Now you might think, but Miss Ashley, that doesn't have a variable. Well, it does. But you could look at it this way, that the variable for negative 7 could be x to the 0 power, because anything raised to the 0 power is equal to 1. So x to the 0 power would be negative 7 times 1, which equals negative 7. So that's why it would still count as a polynomial. So if you look at on the top of page 183, you see 6 expressions. Some of them I have on the board. But those 6 expressions, each of them meets all 3 requirements for being called a polynomial. Number 1, each expression is in the form AXN. Number 2, the numerical coefficient of each expression, A, is a real number. Number 3, the exponent of the variable N is a positive integer, or is the number 0. Okay, let's keep going with the next part. We're gonna skip down to where it says a polynomial of one term, because I've just talked you through this section. Okay, so a polynomial of one term is called a monomial. So polynomial, that's any expression that has this form. If it just has one term like this, it's a monomial. So here we have a monomial. These are all monomials, okay? But if it has 2 terms, it is a binomial. So a polynomial with 2 terms is a binomial. For example, they show you sum 4 plus x is a binomial. Here's one term, here's your second term. So 2 terms, binomial. You also have B, letter B, an example on your page there is p to the 15th power minus 4p. You have 2 terms, binomial. Letter C, your example C, says negative y10 plus 3y. Your first term is negative y10, your second term is 3y, binomial. All right, then we have, if you have three terms, that is the trinomial. So monomial, mono meaning one, binomial, bi meaning two, trinomial, tri meaning three. So three terms for that one. So it shows you A, x squared plus 2x plus 4. You have three terms, trinomial. B, y14 minus 1.6y squared plus 4. Three terms, trinomial. M4 plus 2m minus 1.6. Three terms, trinomial. Okay? So then if you look down there, it says any of the following expressions are a polynomial. Okay? Now I want to call your attention right here to letter B. Now I know a minute ago I said there's no division. That's, okay, I made a mistake. There is some division. With your number, your real number, it can be a fraction. Your number can be a fraction. But in other parts of your expression, you won't have division. But your number, your coefficient, that can be a fraction. So it's not just a whole number. So sorry about that, I confused you. I made a mistake when I was explaining. It can be a fraction, all right? So you can have a fraction for A, but in other places, no, just for A. All right, if you look down, let's see. No, go ahead and turn the page. I want you to look at that box. At the top of page 184, this box right here, it says the definition of a polynomial in one unknown. A polynomial in one unknown is an algebraic expression of the form 4x15 plus 2x14 minus 3x10 plus, and so on down the line. It's where the coefficients are real numbers, x is a variable, and the exponents are whole numbers. So it's saying that you have a bunch of polynomials that all have the same variable. Okay, that's the definition of a polynomial in one unknown. So you only have x as your variable. You don't have x and y, x, y, and z, a, b, and c. You just have one unknown, one variable. It can be x, it can be c, it can be z, just as long as it's only one unknown. Then it says, thus, none of the following expressions is a polynomial. Here's where I want to show you the division that's not in a polynomial. So A, you have 4x negative 3. Okay, for letter A, it can't be a polynomial because the negative 3 in your exponent. That's not a polynomial because your exponent is not a whole number. For letter B, you have negative 6x plus y over z. It's not a polynomial because it's not in the right form. You have division of variables and you can't have that. Letter C, and you also have addition in there. The 6x plus the y, then divided by the c, or the z, it can't be like that. Letter C, negative 15y negative 5. Okay, again, you have a negative exponent there, so it's not a polynomial. All right, now look at where it says definition of a polynomial. So your box in the middle of page 184. A polynomial in one or more unknowns is an algebraic expression having only terms of the form a, xn, ym, zp, where the coefficient a is a real number and the exponents n, m, and p are whole numbers. Okay? So your exponents have to be whole numbers. So there you can have multiple variables within a polynomial. You can have multiple variables within a polynomial. You just can't divide those variables, okay? Thus, the general definition of a polynomial has the same restrictions that are given by the definition of a polynomial in one unknown, namely, number one, the numerical coefficients of the individual terms must be real numbers. So a has to be a real number. The exponents of the variables must be whole numbers, okay? So real number for a, whole number for n. You can have all kinds of variables. So the following can therefore be called polynomials in more than one variable. A, you have x, y, z squared m. B, 4x15, ym3 plus pq5. That's a binomial, you have two terms. C is negative x squared p4 plus 2. Again, binomial, 2 terms. Okay, let's talk about another term. The degree of a term of a polynomial is the sum of the exponents of the variables in the term. Okay, so degree is just how we can label polynomials. So 4x3, the degree of 4x3 would be the addition of all of the exponents. Well, my only exponent is 3, so it has a degree of 3. For 6xym, each of their exponents is an understood 1. 1 plus 1 plus 1 is 3, so it has a degree of 3. Here you have 2x squared plus y. Y has an understood exponent of 1, so 2 plus 1 is 3. So it also has a degree of 3. Here I have 4x squared and 3. 2 plus 3 is 5, so it has a degree of 5. Here I have 3y5, so it also has a degree of 5. For the degree of a polynomial, so the whole thing, so here's a polynomial, it's a trinomial, I have more than one term. I find the highest degree, the term of with the highest degree, and that's the degree of the polynomial in all. So this term has a degree of 2. Let me change my colors here. This term has a degree of, well, 1, 2, 3, 3. This term has a degree of 1. So this is the highest degree, so the degree of the polynomial is 3. Here, this one has a degree of 5. This term has a degree of 1 plus 3 is 4. This term has a degree of 2, and this term, well, there's no variable, so its degree is 0. My highest degree is 5, so that's the degree of my polynomial overall. All right, and that's degree. That's pretty simple, right? Polynomials are usually written in descending powers of one of the variables. So if you look at the polynomials at the top of page 185, they are written like this, okay? The very first one is written in the descending powers of x. So you see x5, then x4, then x2. So the variables are getting smaller as you go down. The next one, you see x4, x3, x, which means x1, 6. Okay, so the second one is written in the descending order of the descending exponents of x. Sorry, trying to make sure I said it correctly. Then you have the third one. The third one actually has all the same terms as the second example, but this time is written in descending order of m. So you have m5, m2, m. So it really doesn't matter. It's just up to you how you choose to write it. It's just that it's normally given that we write these in descending order. Okay, we're going to now talk about addition of polynomials. But our lesson's getting kind of long, so what's going to happen is I'm going to stop the lesson here, and then there's part 2. Still today, guys. You're not done. Go look for part 2 now. We'll talk about addition of polynomials.